that we have to become a leader in defense technologies. So let's look at the present defense ecosystem and whether that is suitable to meet these challenges ahead. If you look at today's defense ecosystem, defense R&D is mostly done by DRDO, supported by academia and MSMEs. The design and development of systems also happens mostly in DRDO, whereas the production happens in PSUs and private industries based on TOTs either from DRDO or from abroad. If you look at the defense capability pyramid here, if you really want to become Atmanirbhar, you have to build capacity and capabilities in all the steps which I have listed in the pyramid. It is not just enough to have system configuration and design capability or system engineering and integration capability, but you have to build capabilities in subsystem, components, device manufacturing, and of course materials, and that too at industrial scale, not at lab scale. This is a challenge that we all have to overcome if we have to really become Atmanirbhar and a leader in defense technologies. So if you look at our current ecosystem, it is pretty much linear with people working in silos. The basic research happens in academia. We then translate it to applied R&D in DRDO labs and eventually then further translate it into production in industry. To meet the emerging challenges, this kind of ecosystem is not optimal. We will need to increase the interaction between the academia, the industry and the R&D organizations. And a linear scale or the linear development cycle has to become an integrated approach where you look at the manufacturability, the producibility at the beginning of the development cycle itself. So what do you need going ahead? You need more participation by industries in design and development. You have to encourage startups and MSMEs who are much more flexible to get into the innovation. You need involvement of academia in basic and applied research, especially in futuristic technologies, because the innovation has to be driven by R&D in futuristic technologies. Only then can we achieve leadership. We need to create a lot more test facilities and infrastructure. As Dr. Saraswat mentioned, it is not enough to just simulate on computers. You have to actually build prototypes, test it, and then optimize your design. Capacity building is another very important thing if we have to do, and academia is going to play a big role if we have to build capacity. And I'm happy to see so many students participating in this meet, because you are the future. Only when enough people and bright people in the country take up R&D as a profession can we achieve Atmanirbharta and leadership. We have to emphasize on disruptive technologies, because we have to admit that we are 10 to 15 years behind the traditional technologies. So if you have to catch up and leapfrog, we have to emphasize on these new emerging technologies. Only then can we hope to achieve leadership. And civil-military fusion is very important. In the past, it was the military technologies which led to their final utilization in civilian applications, whether it is the internet, whether it is telecommunication. But now, in several technologies, especially AI, ML, quantum technologies, the civilian sector is far ahead of the military. And unless we leverage the expertise that is available in the civilian sector in the country, we will not find it easy to achieve leadership. So what do we need to build? Because it has been shown that countries which don't invest in defense R&D cannot prosper. Only when you are secure and you have enough deterrence can you grow economically and your society can grow in other aspects. Because history has shown that though defense R&D is costly, not investing in defense R&D is even costlier. So we have to invest in building next generation capabilities, whether it is in underwater domain awareness, space situational awareness, ISR capabilities, robotics and unmanned technologies, manned and unmanned teaming. Future wars are going to be fought with autonomous systems. But you need the ability for these autonomous systems to work synergistically with manned systems. So this manned, unmanned teaming technologies are going to play a key role in any future battlefield. Cyber defense, as I mentioned in my introduction, not only cyber defense but cyber deterrence, like we have nuclear deterrence. You have to build capabilities in the cyber domain if you have to win any future war. Secure communication and network-centric warfare, as I mentioned earlier, are other areas where we have to build significant capabilities. These are some of the future platforms that we are working on and would be developed in the next 5 to 10 years. The 5th generation stealth advanced medium combat aircraft, the twin engine deck-based fighter for our aircraft carriers, remotely piloted strike aircraft, high altitude long endurance UAVs or HALEs, stratospheric airship or high altitude platforms which can give you persistent surveillance in a battlefield, AEWNC or airborne early warning and control aircraft, which is basically an eye in the sky, which allows you to plan your battles and do battlefield damage assessments. High endurance autonomous underwater vehicles, indigenous conventional submarines, light tanks, future infantry combat vehicles, unmanned ground systems, and robotic soldiers, just to name a few. These are some of the systems that we have started working and should be developed in the next 5 to 10 years. When it comes to next generation weapons, systems and sensors, some of them I have listed here: long range, hypersonic, glide and cruise missiles, with the air defense and missile defense systems becoming increasingly more accurate and very good. If your missile systems have to survive, they have to operate at hypersonic speeds. Very long range air-to-air missiles, directed energy weapons based on lasers as well as microwaves, electromagnetic railguns, long range multi-barrel rocket launchers, supercavitation torpedoes. Normal torpedoes operate at about 50 knots. These supercavitation torpedoes can operate up to 200 knots. So, defeating a supercavitation torpedo becomes extremely difficult. Very long range radars, very long range sonars, ELINT and hyperspectral capabilities, EW systems, EW is electronic warfare. Whoever dominates the electromagnetic spectrum is likely to win the future wars. High thrust to weight ratio aero engines for our fighter aircraft. This is one very complex technology which we have to master if we have to get real Atmanirbharta. Electric propulsion for our ships, electromagnetic aircraft launching system or EMALS for our aircraft carriers for launching aircrafts. If you come to new and critical technologies which we need to master, I have listed out some of them. I will not go through them because of lack of time. But most of you are aware of these technologies, and we have to increase our focus not only in academia but also in startups, MSMEs and our R&D labs to not only master these technologies but also achieve leadership in these technologies. So at DRDO, we have identified all these various technologies. You don't have to read them here. They are listed on our website. And you can, if you are interested in working in defense technologies, you can choose the technologies which interest you, and you can definitely contribute to defense R&D going ahead. We have also opened 15 centers of excellence in leading academic institutions. We call them DRDO Industry Academia Centers of Excellence. And for each of the Center of Excellence, we have identified certain domain areas. And these Centers of Excellence are going to act as a hub and spoke model, where we hope that what MIT and Stanford achieved in the US, these Centers of Excellence will result in the same kind of ecosystem being created around these Centers of Excellence in our country. We also have proposed a scheme, TDF scheme, where we can fund R&D in startups, MSMEs as well as large industries, where up to 50 crores can be sanctioned for R&D within the industry. And two of the gentlemen, Dr. Saraswat and Mr. Kakurkar, who are here present today, have played a key role in helping us in defining how such a scheme can be done. This will allow us to do cutting-edge R&D in startups using this scheme. But one thing which we need to address as a country, if you look at how much we spend on R&D as a nation, we spend about 0.65% of our GDP. If you look at other countries, they all spend between 2 to 3% of their GDP, and South Korea even spends close to 4.8% of its GDP in R&D. So we definitely need to improve on our spending on R&D. Our private sector also has to chip in. The private sector R&D today is confined mostly to the pharma sector and some other sectors such as maybe IT, but it needs to improve significantly in other technology areas if we have to become a leading nation going ahead. Even if we look at our defense R&D spend, we spend less than 5% of our defense budget on defense R&D. Most countries spend between 10 to 15% of their defense budget. We have told the government that this funding has to improve in the next few years, and the government has promised us that by 2030, we should go to a figure of about 10%. Hopefully, this will result in a significant fillip to funding R&D, not only within DRDO, but within our academic and industrial ecosystem. One thing which we need to address is, as a society and especially in government, we are very averse to risk and we are very intolerant to failure. If we take up a project, it has to succeed. Otherwise, we get audited, we have to answer in Parliament why this infructuous expenditure has happened. I think if you want to do cutting edge R&D, you have to learn to fail. Failure is not bad. Failure teaches you a lot of things and it can be a stepping stone to your next success. You have to fail, but you have to fail fast and you have to learn from your failures and move ahead. This is a cultural change which needs to happen within the country and especially in the government sector. So to summarize, the road ahead is going to be both challenging and exciting. There are plenty of opportunities for R&D, especially in defense. The students who are here are going to play a key role in transitioning India from a developing country to a developed country by 2047. And also not only a developed country but also a technology leader. Thank you very much for your kind attention.
Thank you, sir. I now request Professor Ashutosh Sharma, President of INSA, to formally induct Dr. S.V. Kamar with a scroll and Angavastra.